Okay, so today we're going to talk about number 16 on the free response packet. So let's see what we got here. Particle moves along the x-axis, so that's velocity at time t from 0 to 6 is given by the differential function v, whose graph is shown above. So again, very first thing we should do is they've given us some information. This function right here is a velocity function, right? So if we were to take the derivative of it, we'd get an acceleration. If we were to integrate it, we'd get a position. So again, we are given a velocity function. The velocity is 0 at t equals 0, 3, and 5. And the graph has horizontal tangents at t equals 1, right? So we have a horizontal tangent. And t equals 4, another horizontal tangent. The area of the bounded regions by the t-axis and the graph of v from those respective intervals. So the area is, for each of those intervals, this is 8. This is, I just lost it. This is 3. And this right here is 2. Just to be clear, one more time. This shaded region has an area of 8. This shaded region has an area of 3. This shaded region has an area of 2. Now, we haven't discussed sign, right? If it's below the x-axis, or in this case, the d-axis, then it's going to be negative. If it's above, it's going to be positive. But again, it's because we're talking about area, and we don't really sign it. But if we want to sign our areas, we could say that this region right here is negative 8. This region right here is positive 3. And this region right here is negative 2. Okay? Let's see what else we know. At time t equals 0, the particle is at x equals negative 2. So they're giving us an initial condition. So they're telling us it passes through the point, what was it, time 0, negative 2. So it passes through that point. Okay, all good information. Let's see what we can do from there. So from 0 to 6, find both the time and the position of the particle where the particle is furthest left. Just find your answer. So furthest left. So because we're talking about a particle, right, we're basically talking about a maximum or a minimum. When we find a maximum, we're finding something that's furthest right. When we're finding a minimum, we're finding something that's to the furthest left. In this case, we're finding an absolute maximum, in this case, we are finding an absolute minimum. So let's think about what we need to do in order to find an absolute minimum. In order to find an absolute minimum, we need to do a couple things. One, we need to know what the critical numbers are. In this case, I think you'd agree, the critical numbers are where the derivative equals 0. So we have critical numbers at 3 and 5. We also have to evaluate the endpoints. So we have to evaluate time equals 0 and time equals 6, right? So when we want to find an absolute minimum or maximum, we look at the endpoints, we look at the critical numbers, and then we say this is the largest or this is the smallest. In this case, whichever is the furthest negative is the furthest left, whichever is the furthest positive is the furthest right. So if we were going to make a quick sign chart, and I know this is actually not really a sign chart problem, but I'm just going to make one to look at it because I like sign charts. They're fun. So let's see what we got here. We got our critical numbers at 3, and we got our critical numbers at 5. And then we have our endpoints at 0 and 6. So to the left of 3, the graph lies below the x-axis. So the velocity is negative. To the right of 3, it's above the x-axis, so it's positive. So we have a relative minimum right there. And then to the right of 5, it's negative. So we have a relative maximum right there. So let's go through and answer this question. So what I'm going to just kind of take this in order. And what I mean by that, so I'm going to evaluate, so the original function was this x particle. So I'm going to say, what is x of 0? And the nice thing, of course, is they gave us that. So x of 0 is negative 2. So I have taken care of one endpoint, right? I'm going to have to find x of 0, x of 3, x of 5, x of 6. Now, you're probably saying, well, can't you ignore x of 5? It happens to be a relative maximum. Yes, I could. I absolutely could have. I could ignore 5 because it is a relative maximum, so it's not a relative minimum. I'm just going to include it because I think mathematically it's just going to be easier than writing out, hey, look, this is, there's a maximum here and da 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 da. I think it's easier just to kind of go through and evaluate because these are really easy to evaluate. Let's go find x of 3. So x of 3, I think you'd agree, is going to be equal to x of 0 plus the displacement from 0 to 3 of v of t dt. And which equals, so x of 0 was negative 2. The displacement, right? So I'm kind of going back to here and I'll highlight it just really quickly in orange. This displacement, right, is below the x-axis, so it's negative 8. So I get negative 2 minus 8 or negative 10. Okay, let's keep on going. Now let's go find x of 5. And that's going to be equal. So I just found x of 3. So I'm going to start there now. So I'm going to say it's going to be equal to x of 3 plus the displacement. Sorry, I'm going to raise it up a little bit because you can see my handwriting's kind of going. From, what am I going from? 3 to 5 of v of t dt. So x of 3 we already found was negative 10. Now, from 3 to 5, right, we're going to be adding this piece right here, but it's positive. So I'm going to be adding positive 3. Whoops. And that gives me negative 7. Next, I'm going to go to x of 6. So now I'm going to start, because I already found x of 5, I'm going to start at x of 5. And I'm going to add the displacement from 5 to 6 of v of t dt. And that's going to be equal to negative 7 and plus, well, let's see. Oh, that's below the x-axis, right? It's 2 units, so it's negative. So plus a negative 2, which is negative 9. So I think you'd agree. So remember, because we're trying to find the thing that's furthest to the left, we're looking for the largest negative number. So I think you'd agree this is our candidate. So what I'm going to say to kind of wrap this up, I'm going to say at time, what was it? T equals 3, right? At time, t equals 3, the particle is 10 units to the left, which is the furthest left it travels on the interval from 0 to 6. Okay, let's just kind of quickly backtrack to make sure we're good. And let me just kind of also go through what you need to actually show. So they did ask us to justify this. This part right here, I'm going to do this in pink. This is my justification, not the sign chart, of course. That right there is my justification. I don't need to really go any further than that in terms of my justification. My answer, of course, I had to indicate my answer, and I said my answer is time. They wanted both a time and a distance. So my time, right, was time 3. My distance was 10 units to the left. So important things here. One is that I obviously indicate the time, and then I'm indicating that I'm showing that I recognize that because it's negative, it's to the left this number of units. Those are important pieces there. Okay, let's move on to part B. Let's move on to part B. So I'm going to erase this so that I have some space. What do we got? Part B. For how many values of t where from 0 to 6 is the particle equal to negative 8? Explain your reasoning. Okay, so let's kind of backtrack just for a second. I'm going to kind of go back to what I had written there. So this is actually kind of useful. So maybe I won't get rid of this thing right here because it's actually very useful. Though I'm going to kind of lose my problem now because I'm going further down. So let's go to B. They're asking, where is it -8? So let's just talk this through first. First off, they told us that the function is differentiable. In fact, this graph right here that they gave us, so this guy right here, they told that's our derivative function. Reminder, if something is differentiable, that implies that it's continuous, and that's important because what I'm going to do is I'm going to use the intermediate value theorem. Reminder what the intermediate value theorem says. It says that if I have 2 points, f of A and f of B, and some point that lies in between them, so let's say some value like k that lies in between them. In this case, k would be equal to -8. If -8 is in between two different height values and the function is continuous, by the intermediate value theorem, there has to exist some c on that interval from A to B such that f of c equals k. Okay, that's what I'm going to use here. So let's see what we got specifically. So notice what we have. Remember, this function is continuous. So if we look at our intervals, first off, I'm going to look at the interval. I'm going to get rid of some of my highlights here. This part right here, I'm going to get rid of this just so it doesn't lead to any confusion. It doesn't matter right now for this problem. So first off, let's look at this piece. Notice the height values go from -2 to -10. Because the function is continuous, I think you'd agree this particle, at one point, let's just use inches. I know it's not inches, but let's use inches. Well, actually, wasn't it centimeters? Or was it not? I don't see units. Maybe I might be missing it, but I don't see any units. So let's just use inches for right now, just for talking purposes. I won't include, obviously, inches in my written part. But at time 0, it's -2 inches from wherever it originally it's at -2 inches from, like if you had a number line. So if this were my number line, at time 0, right, it's right here at -2 inches from wherever this 0 point is. Then at time 3, right, it's way over here at -10. Which means, I think you'd agree, if this function is continuous, which it is because it's a particle travel, I cannot, right, there we are, -10. I think you'd agree if this is continuous, so this is the particle traveling along this way, at some point it had to pass through -8. And again, the intermediate value theorem guarantees that. So so it does it once there. Then, let me do this in pink. So at time t equals 3, it's at -10. At time t equals 5, it's at -7. So right here, right, again, it had to pass through -8 because -8 is between -7 and -10, or -10, -7. And then finally, one more time, it's at time t equals 5, it's at -7. Time t equals 6, it's -9. It has to pass through it one more time. So there are 3 instances where the graph, this particle, has to be -8 units away from 0. Okay? So how do we kind of put that together? Let's kind of go through and put that together. So here's what I'm going to say. I'm going to say the particle is at -8 3 times. So I'm going to kind of just state my conclusion. Next, I'm going to start setting up my IVT. Okay, I want to set up my IVT. How do I set up my IVT? I'm going to first off say that it is continuous. So since the function is differentiable, it must be continuous. So I've established that the function is continuous. And again, I can do that just by the fact that it's differentiability. There's a theorem that says differentiability implies continuity. That's the theorem that I'm using. That's the theorem that I am using. So from there, kind of being a little redundant here, but that's fine. So I've said there's three intervals. Let's go through those intervals. So interval one. So I'm saying on 0 to 3. How do I know that? Well, so now I'm taking care of the second part. So remember the second part of IVT. I have to show that the value that I'm looking for is in between two different values. So we happen to know that x of 0, which equaled, what did x of 0 equaled, which was -2, is greater than or equal to -8, which is greater than or equal to, what was that next one? It was x of 3, which equaled -10. So I've shown that -8 is in between those two numbers. And I'm going to do the same for my other two intervals. Sorry, I forgot one there. Let's put that in. X of 5 was what? X of 5 was -7. Just to be, well, let me finish that part, and then I will kind of go through what I'm about to say here. Okay. So what have I done? I've shown, so first off, again, I've shown that -8 is in each of these intervals, right? It's in between each of these numbers. Just to be clear, I didn't need to be so verbose. Yeah, I'm using the word verbose a lot. Wow. Word of the day is really working out for me here. Um, I could have just said, I could have summed this down. So like taking the first one, I could have just said x of 0 is greater than or equal to -8, which is, um, greater than or equal to x of 3. Because I already showed what those values were, I just was trying to be a little bit more, here I'm really trying to draw it out. But again, they would have given me full credit if I had just stayed that because I already found those values in part A. But anyway, here we go. So I've established two things now. One, I've established that the function is continuous. I did that there. Two, I've established the fact that -8 lies in between three different segments. So my last part is I need to come up with my conclusion. So now I'm just going to use my theorem. So that's it. Big things that we have to point out. So if I were grading this, here's what I'd be looking for. One, of course, that you indicated three different intervals. That's the first thing. Second, that you explained how you knew it was continuous. Third, how did you know it was on each of those three intervals? So I showed that it's in between each of these two. -8 is in between two different values, right? And it's between -2, it's between -10, it's between -10, it's between -7. Dot, 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 dot. And then finally, I named the theorem that I am using. Super important, right? I have to say by IVT. I guarantee you they are checking to see, did you use IVT? Okay, that is letter B. Let's move on to letter C. Letter C. What do we got? I'm not going to ratio it just in case I need. On the interval from 2 to 3, nope, I'm going to be good. So on the interval from 2 to 3, Is the speed of the particle increasing, decreasing? Give a reason for your answer. So I don't know if we've ever talked about speed. Um, I usually kind of save it for the review, so we may have talked about it before, but I'm not positive. So before we begin this, let's just talk about speed a little bit. So in order for an object speed, so an object speed to be increasing, the sign of the velocity function and the acceleration function have to be the same. Either they both have to be both positive or they have to be both negative. If the speed of the object is decreasing, then their signs are opposite, right? So one's positive, one's negative. So that's going to be kind of our definition here. So let's look what we have. Let me clean up my graph here a bit. So we are looking at the interval from, what did they say? We are looking at the interval from 2 to 3, and we want to know, is this object speeding up? So here's what I'm going to say. So first thing I'm going to look at the sign of the velocity function, which is the sign of this graph right here. So I'm going to say v of t. Notice it's below the graph, right? So it's negative, so it's less than 0 on 2 to 3. I've established that v of t is negative. Again, how do I know it's negative? Because it lies below the t-axis. So I've established that the velocity is negative. Now I got to look at the acceleration. What is the acceleration? So a of t, which equals v prime of t. Now, let's look at v prime of t. V prime of t is going to be the slopes of the tangent lines to this graph on this interval. Notice all those slopes are positive, right? All those slopes are positive. So in other words, it is greater than 0 on 2 to 3. So notice what we have. The velocity function is negative. The acceleration function is positive. Therefore, the speed of the object has to be decreasing because the signs are different. So I will say you know what? Let me just do this really quickly. I'm going to just try this out really quickly. It'd be easier for you guys to read and faster for me to type. I don't have anything to write here, so I'm just gonna type this because let's do that. That way it's just easier for you guys, I think. So the particles, how do you spell particle? Sure, the particle's speed is decreasing. And how do I know it's decreasing? It's decreasing because, let's actually make that a little bigger. That's probably hard for you guys to see. Let's go to 14. How's that sound? Okay, so the particle speed is decreasing on, what was our thing here, from 2 to 3? Because that's it. That's all I gotta say. So the particle speed is decreasing on 2 to 3. Why? Because the signs of the particle's velocity and acceleration are different. That's all I gotta say. If it had been increasing, I would have said that their signs were the same, either both negative or both positive. That's all I gotta say for letter C. Okay, let's move on to D. I kind of like that. I kind of like typing out. It was probably a lot better for you guys and definitely quicker for me. Okay, let's see what we got. Letter D. During what time interval, if any, is the acceleration of the particle negative? Justify your answer. So this is kind of strange. And the reason I say it's kind of strange, if you were able to answer letter C, you should be able to answer letter D. C is actually a harder question than D. I mean, not like crazy harder, but it's slightly harder. So the acceleration is negative when the slopes of the tangent line to the graph of V are negative. So I think you guys would agree, right? Slopes of the tangent line are negative here. It stops right here because we were told at time 0, there's a 0 there. And they're also negative from here. I'm just going to highlight these areas. So it's negative. All the slopes of the tangent lines are negative from there and negative from there. So what am I going to say? Actually, let's type it out. Cool. Cool, 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 cool. Okay. Apparently, I need to erase that. So let's see. The particle's acceleration is, what were they asking? Were they asking for negative or decreasing? Negative. By the way, I'm using closed brackets here. It doesn't matter. You could use open brackets, open interval, or closed interval. It really doesn't matter. They won't take off. And I misspelled that word. I don't know how to spell it. Particles? Sure. Probably should be a apostrophe. I have no idea. Okay, maybe. Okay, so again, it could be open or closed. It doesn't matter. So I'm saying the particle's acceleration is negative on 0 to 1, 4 to 6. How do I know? The reason I know is because the velocity, because v of t is decreasing. This is important. They gave us the graph of v. So I am taking the derivative. How am I doing that? I'm showing I'm taking the derivative by using a derivative word, decreasing. So it's decreasing, which means I'm looking at the acceleration function on those intervals. Okay, that's all there is to that. Let's blow that up just in case you guys are having trouble reading that. Probably not. Probably not. Okay, so again, one more time, just because we haven't talked about speed a lot, or maybe ever. When you are discussing speed, you look at, if you want to determine if a function speeding up or slowing down, you look at the side. You have to look at both the velocity and acceleration functions. If their signs are the same, either both positive or both negative, then the object is speeding up. If their signs are different, it's speeding down. So that's for letter C. For letter D, when we want to talk about the acceleration in this one, right? If I want to talk about acceleration and I'm given a velocity function, then I'm looking at the slopes of the tangent lines. So in this case, going back to my graph, the slopes of the tangent lines to the graph are all negative on the highlighted intervals. Therefore, the acceleration was negative. And again, I had to use the word decreasing because we were looking at the derivative of this, right? And by using the word decreasing, I'm saying I'm taking the derivative and I'm looking at the derivative. Okay, so I can't say positive or negative there because I wasn't given the acceleration function. Anyway, that is problem 16. There was definitely some interesting and fun stuff on that one. I liked that one very much. Anyway, I hope that you got something out of this. If you have, of course, any questions, please feel free to ask me. Kind of shoot me an email or whatever, or hit it up in our next Zoom meeting. Actually, it would be better, I would prefer, because I talked about this before. If you have questions on these, send me an email, and then in my Zoom meeting, I will address it. Okay, so if you're like going through this and you're like, I don't know, just write down the question, send it to me an email, and then I'll address it either in a Zoom meeting or a follow-up video. If there's a lot of questions, I'll probably just do it on a follow-up video. Otherwise, I'll probably just hit it in the Zoom meeting whenever we do that. Okay, so again, I thank you for your time. As always, please do not like, comment, or subscribe, and I will talk to you later.